Okay, this is the fourth video in the series of the definition of the derivative, and what we have been working with for the first three videos has been this version of the definition of the derivative. And if you go back and take a look, or even if you just can't remember or need to pause and go back, feel free to do that. But this is basically the formula for slope. It's y2 minus y1 over x2 minus x1. I know you can't see it here, but go back in a video and you'll be able to see that. And this is computing the slope at 2 points that are really close together. So think about h not quite being 0, but approaching 0. So that makes this x value a little bit different than this x value. Okay? The same thing goes. In this video, we're going to be using this version of the definition of the derivative. And once again, you see y2 minus y1, here are the x values, over x2 minus x1. And this is again slope. And it's the slope between 2 points that are really close together, because notice that x is approaching a. X is not equal to a, but it's as close. These two things are as close together as you can possibly imagine. Okay, so we're going to look through the same example we did in the previous couple of videos, and we're going to take a look at it in this form. And if you remember, when we use this, at some point you're able to factor the numerator enough so that the quantity h up here and the quantity h down here cancel. We're going to see something very similar in this process. Up here, we're going to see the quantity x minus a in some form or another, and that's going to cancel with this quantity x minus a, and that will allow us to evaluate the limit. Okay, so let's take a look at how this works. So x is approaching 2 in this problem. Okay, so as I set up the limit, and we're going to start to look at the derivative, the slope of the tangent line in this form. So if we're looking at the function f of x, or the function f, the slope of the tangent line of f is signified with f prime. The way we say this is f prime of x. So f prime of x equals, we're using this one, the limit as x approaches 2, that's what the problem says here, we're approaching 2, of f of x minus f of 2 all over x minus 2. And if you recall, we found the slope to be 12 in the previous example. I think it was video 2 in this series. All right, so we're going to just start evaluating this. The limit as x approaches 2. Let's see, f of x is 3x squared plus 7. Minus f of 2, maybe we look up here, f of 2 is 4, 12, 19. All over x minus 2. So a little simplification here, we'll keep the limit going. In the numerator we have 3x minus 12, 3x squared minus 12. And in the denominator x minus 2. I'm going to skip a couple of steps as I move to the next step here. Imagine factoring out of 3, x squared minus 4, right, if we factor a 3 out of here as well. So that x squared minus 4 is a difference of squares, and that factors into x plus 2, x minus 2. So all this together factors into 3 times the quantity x plus 2 times the quantity x minus 2, and we're going to look at that here. Limit as x approaches 2 of all that factored. Okay, and notice what's nicely going to happen here. And remember, video 2 we got an answer of 12. And in video 2 we noticed h, the quantity down here, canceled with a quantity h that we had up here through the algebra. And that's happening here as well. So when the x minus 2's cancel, we have this limit as x approaches 2 of 3 times x plus 2. And now when we evaluate this limit, we get 12. So the slope of the tangent line on this function right here, it's It's a quadratic function, so it's going to be a parabola. So when x is 2, the slope is going to be 12. And so I've on GeoGebra, I've kind of demonstrated this. So notice the scales are a lot different. I had to squeeze down the y scale here, and here's your x scale going by halves basically. These are going by fives. Here's the point 219, and I graphed the line. Okay, I graphed the line going through 219 with a slope of 12. Here's your point slope form if you want to think about it that way. And you can definitely see that it is a tangent line right there to the graph, to the function 3x squared plus 7. Okay guys, hope this helped, and good luck.